Hi, I'm Eric Dibble, Regional Sales Manager for HF Scientific. This video is going to go over the CLX flow paths and some alarms associated with the flow path. Let's start by talking about water coming into the analyzer. The water coming into the analyzer through the 1/4 inch OD tube needs to be above 5 psi. The water pressure is controlled by the intake regulator. The regulator protects the intake solenoid by ensuring the water pressure is in the correct range for the intake solenoid to operate properly. The intake solenoid fires, which allows the sample cell to fill and mix. After the reaction, the drain solenoid will open, which allows the sample to drain. There are a few errors that can pop up from issues in this flow path. We will start with the NPRG or PRG errors. These errors mean the cuvette is not draining properly and the photo eye is still seeing water inside the cell when it's supposed to be empty. These alarms mean the analyzer does not believe it's draining, the NPRG alarm, or believes it's draining too slowly, the PRG alarm. Both of these alarms are based on optical detection, so the first thing that we want to do to troubleshoot is determine if there is still water in the cell causing these errors, or if it's external interference on the cuvette. We can do this by visually inspecting the cell, to see water inside the cell and to see the NPRG error on the screen. If there is not water in the cuvette, you might want to take the cuvette out and ensure there is no moisture on the cell that is causing the error to come up. Clean and dry off the cuvette. Also make sure to dry off the inside of the optical block with a lint-free cloth. Any water inside there will cause some interference and give you a false reading. Having a tube attached to the bottom of the analyzer can cause back pressure in the line and not allow the analyzer to drain. Air gap the drain as the first line of defense in troubleshooting. The NPRG error can also be caused by issues on the front end with the intake solenoid. If you have the drain air gapped and the intake solenoid is not firing, there should not be water inside the cuvette. To test this, put the analyzer into a hold mode and verify there is no water coming into the analyzer. If you see water flowing in, you may have an issue with the intake solenoid. We'll try it. Service until the analyzer says hold. At this point in time, the cuvette should be empty if you do not have an NPRG error. As you can see, there is still water inside this cuvette. This shows us that since we have a tube hooked up here, we're getting some back pressure that's not allowing the analyzer to drain. We are going to try taking off this line to see if the analyzer will drain, and then we can test to see if our intake solenoid is blocking. We have now installed a funnel on the bottom of the CLX. We no longer have a tube attached to the hose barb. We're going to try to drain the cuvette and see if it drains. If it drains and clears the NPRG, we know we have solved the issue. As we can see, once I hit the exit button twice, the cuvette drained. So that told me that the tube on the bottom was our issue. We're going to check one more thing to make sure that we don't have any leak by from our intake solenoid. We are again going to go into the hold mode by pressing the service button and waiting for the screen to say hold. At this point in time, we should have no water inside the cuvette. As we can see, there's no water. We know it's drained, and we can say that our intake solenoid is not leaking by. If there was water coming into the cuvette at this time, when you verified that it's drained, then you know you have an issue with your intake solenoid. The next flow path errors are based on the flow to the analyzer, and they are called fast and slow. We will tackle the fast alarm first. Fast is the alarm the analyzer will throw when the water coming into the cuvette is coming in too quickly. The analyzer wants the flow test, which we reference in the CLX setup video, to be between 5 and 22 clicks. These clicks are just the intake solenoid firing. If the fast alarm is on, that means that the cuvette is filling in less than 5 clicks. There is too much water coming into the analyzer. To fix this issue, we need to adjust the regulator by turning the regulator to the left. By turning the regulator to the left, we're actually letting less water in. We need to remember that the regulator is not like a normal valve. Left means less water and right means more water. The next thing you want to do is to visually inspect the cuvette during the flow test. make sure you can see water coming into the cuvette in a stepwise fashion. The water should not be flowing steadily into the cuvette, but instead coming in very small, distinct increments. Once you have set the flow test to 10 to 12 clicks, let the analyzer run to ensure the error has cleared. With an air gap drain and a consistent 10 to 12 clicks on the flow test, the NPRG error should be cleared. If it has not cleared and you can still see water inside the cuvette, it may be time to clean the lines on the drain solenoid. WATR, or water, is a common alarm that will be seen with the slow alarm. WATR means the analyzer is not getting any water into the sample chamber. Start by adjusting the regulator to a 10 to 12 on the flow test. If you cannot get enough water to satisfy the flow test, you need to look at blockages in the line before the analyzer. Start by making sure your valves to the analyzer are turned on. This might be a good time to clean out the T-strainer and hook up a pressure gauge to ensure that you have at least 5 psi on the line. If you are replacing a competitive analyzer, you may have a standpipe which will cause the pressure below the specs of the CLX. We can see on this analyzer that we had a water alarm, and then we checked and made sure we turned our water on. As soon as we turned the water on, we should get the water alarm to go away as soon as the analyzer goes through its first sample cycle. We can see that there is now water inside the sample chamber, which lets us know that we have cleared the water alarm and the analyzer will start running normally again. The next few alarms have to do with the solenoids and could be in conjunction with the flow path errors above. The alarm SOL0 is an error with the power supply and is telling you that the analyzer cannot open the solenoids with the power provided. Check to make sure the analyzer is wired correctly. You may also have to do a power cycle to clear these alarms. SOL1, SOL2, and SOL3 are errors for the intake solenoid, drain solenoid, and reagent pump solenoid. These errors tell you the power to one of the individual solenoids is bad. Try to unhook and rehook the alligator clip on the affected solenoid. You may also want to put the analyzer into a hold mode. Once you go into hold mode, this will clear all the alarms associated with the SOL0 alarms. SOL1, SOL2, and SOL3 are errors for the intake solenoid, drain solenoid, and reagent pump solenoid. This error tells you the power to one of the individual solenoids is bad. Try to unhook and rehook the electrical clip that's on each individual solenoid that's affected. GRN0, GRN1, GRN2 all have to do with the green lamp on the CLX. They indicate that the lamp is blown or stuck on. Refer to the HF Tech support team for more help with GRN issues. Thank you for watching this video. If you have any more questions on the CLX, please reach out to the HF Scientific Tech support team.